Good morning, ladies and gentlemen. Welcome back. We are going to continue on mineral classification, part 1, with the third and fourth mineral classifications to help you continue with your mineral identification lab sheet. Let's get right into it. First of all, we finished discussing color, okay? Color and luster. You should know what those are. Let's move on now to streak test. Okay. This is another way to help identify a mineral, is to perform what's called a streak test. You'll need a piece of unglazed porcelain tile, and you will streak that mineral in question across it. The colored powder residue that's left behind on the streak plate is called the streak. Minerals do not always have a streak. Some of them do not. Or some do not have the same color as the mineral itself. For example, if you strike gold on a porcelain tile plate, it will come out yellowish. If you strike fool's gold or iron pyrite, it will come out as being black. The streak test, though, only works for minerals that are softer than the streak plate. The streak plate is a 6.5 to a 7 out of 10 hardness. Anything at that number and above will be very difficult, if not it at all will not leave a streak color on the porcelain tile. It will actually cut the tile. That's the third classification. The fourth classification is a mineral's cleavage. Okay? By definition, cleavage is how a mineral breaks along smooth, flat surfaces. Or another definition that I was taught in my grad program is it is considered or called the plane of weakness, along which a mineral will cleave or split when impacted or otherwise fractured. The way cleavage is aligned is due to the arrangement of the atoms at the atomic level. And it's important to note that just because a mineral is smooth doesn't necessarily mean it has good cleavage, because we talked about it breaks along a smooth surface, right? It doesn't necessarily mean it has good cleavage. Another good example would be quartz. Quartz has smooth crystals if it can grow without interruption or interaction with other crystals. It will grow a prism. Sometimes double terminating prisms. Oftentimes we see them as a single terminating prism that has nice flat sides on that. If you were to break that quartz crystal, it would not break smoothly. As I am very aware that you've probably broken glass sometime in your life, and it doesn't break into smaller windows of the same dimensions or the same shape. So because of that, it does not have good cleavage. Quartz would actually have no cleavage. It breaks conchoidally, so it has very different shaped breaks. It's a shattering form, not a particular pattern so much that it breaks into. A good example I would give for this is if you were to take a piece of halite, a chunk of halite, and you were to hit that with a hammer, it would break into smaller pieces of halite, and at the atomic level, halite is a cubic form. And so a larger chunk of halite broken will create smaller cubic shapes, because it breaks along those planes of weakness, or those cleavage planes. So just a little added info there. For our purposes, we're going to primarily be concerned with whether or not a mineral has excellent good or no cleavage at all. One way to tell is to move a mineral around in the light to see if you get a sparkly, shiny glint to the mineral. If the light reflects very well back into your eye, then you have good to excellent cleavage. A mineral that doesn't have good to excellent cleavage reflects light back in too many directions, therefore does not shine like a mineral with cleavage. You can demonstrate this effect using aluminum foil. When aluminum foil is flat and brand new, as you tear it off and you hold it in the reflection of the sun, you will get concentrated light in a very few directions, if not one direction. But if you crumple that piece of tinfoil up and then uncrumple it, the tinfoil will then reflect light or scatter light in many different directions and not be concentrated. That would be considered no cleavage. And then here are some examples. Mica is like a book. It's a stacked pattern of one directional planes of weakness or cleavage planes. Feldspars have at least two planes or two directions at 90 degrees in this case of cleavage where it broke from. That is considered excellent. Calcite is a rhombic shape but still has these multiple planes of cleavage. And then halite is cubic as in nature, as I mentioned earlier. Therefore, it breaks in all three sides with at least 90 degree directions. Therefore, it's perfect cleavage. Okay. Refer back to these diagrams. They will help you visualize the different types of good to excellent cleavage and what non-cleavage or no cleavage would look like, or would it not have, as these planes of weakness clearly visible. Okay, your job is to individually use the streak plate and your knowledge about the mineral. You're going to write down again in the gray line what you think the streak color is, and then classify as well whether the mineral has excellent, poor, or no cleavage. I should say excellent, good, or no cleavage at all. Now then you'll compare your answers to your group and write your final choice in the non-shaded cells with your group. Alright, get to it, ladies and gentlemen, and good luck and get everything taken care of. And that shall be it.